Okay, this is Zephaniah working on the exam problems for differential equations. This is question number 1, where we're looking to talk about separable, exact, and linear differential equations. First, I wanted to talk a little bit about linear to determine if a differential equation is linear. It has to have no powers on the y variable, or the variable that we're trying to solve for, and no derivatives of that variable multiplied together. So we worked a lot with different types of linear equations. Going to separable, it was a first-order differential equation where the first derivative of y with respect to x would equal a function of x, y, that could be written as the multiplication of a function of x times a function of y. So that would look like, anything like this, where you have dy over dx is equal to, anything, 2x times, y plus 3 or something like that. So you could separate the variables out into their individual spots and multiply those together. Looking at first-order linear equations, the general form is written, the standard form is written here. This is the general form, where you have a constant, you have a function of x multiplied by the first derivative of y with respect to x plus a separate function of x times the function y, equaling a function of x. Now, of course, if the function g of x equals 0, that's homogeneous, and the homogeneous we write in the standard form dy over dx plus p of x, some function of x, times y, equaling the function f of x. And our solution is going to take the form of this right here, where we have y equaling yc, the solution of the homogeneous, where this g of x is equal to 0, plus yp being the particular solution. That would be if g of x was equal to something that was not 0. For exact equations, typically we would see them first in this form, where some function of x and y, m, and some function of x and y, n, are taken their partial derivatives with respect to x and y equaling 0. The first thing that we have to do to know that we can use this is that these functions have to be continuous and have continuous derivatives, and that's just something that you can, depending on the problem, you can tell by looking at them. But this is where the big one for exact equations, we would typically check to make sure that the partial of m with respect to y and the partial of n with respect to x were equivalent. That's how we know that we've got this form, and we can use the methods to solve them knowing that they're an exact equation.